Welcome back to the stream. Yesterday we got our new character artwork, and we also fixed a couple of bugs with multiple inputs so that if you're holding 3 inputs, you don't actually walk anywhere or have an animation. So that's what we did yesterday. Today we're going to be working on our entity system, trying to spawn multiple geckos at once. If you take a look now, we've got the ability to spawn a gecko, and he runs off screen. Now, we need to make sure we deinstantiate this guy once he goes off screen, because we don't want to be keeping track of potentially hundreds of geckos. If we're going to be spawning multiple geckos, we just want to make sure we deinstantiate them once they're off screen. So I think that might be something to do, and we accidentally killed our Tmux session. Okay. Let's re-add this again. Now we've got I think what we want to do first here is just take a look, and we lost all our harpoon data. Okay, that's okay. We'll go ahead and just remake some of these harpoon shortcuts rather, and then we'll be back in action. Okay, let's try this. Cool. Okay, so we're gonna be taking a look at our entity states here. So we know we've got, this is what's making our gecko walk. So we spawn it with a direction of up, and every entity that has a direction of up is getting their upward velocity modified by their walk speed. And their default walk speed is 1 here. Now, what we need to do, I think outside of our entity system, because we need to remove whatever entity is off screen, I think in our scene state, we need to give ourselves a table of entities. We need to populate the entities inside that table, and then cycle through the entities of that table and see which ones are out of bounds and remove them if they are out of bounds, sort of deal. So I think one thing I'd want to check first for that is just to make sure we can print out like the number of entities we have, which would be 1 gecko when we place it in there. Let me harpoon this, and we'll go to our play state. I know we want our play state as well. Okay. So if we take a look at our scene, we need our scene harpooned as well. And let me just, I know we're going to need our constants. I know we're going to need our dependencies eventually. I know we're going to need our entity defs eventually. I know we're probably going to need our player eventually soon, and then map declarations is good. So now we've got access to all those. We can just jump to them in harpoon now, thanks to the Primogen. And we also want an entity and entity walk state, right? We got entity walk state. So that's cool. Okay, so yeah, so today we'll be trying to figure out how to utilize our entity system, and we can spawn a gecko in idle state, and every time a gecko is spawned, it for example, could take 5 seconds to turn into a walk state, and then it walks in whatever direction it is. We'd also need to add in our different directions on our sprite sheet so that we can render the appropriate change animation script for it, or whatever you want to call it. And let's go ahead and let's see. Yeah, let's get our play state, which we've already got. Okay, so the first thing we want to do is go to our scene, which we didn't even harpoon. So let's go get that scene. Okay, so our scene is going to have a self.entities table. We're initializing it to nothing. Okay, now this gecko instantiation here gets made. And then what we're going to do is we're going to insert it into our entities table, and then hopefully we'll have access to that, and then we can write a script to delete them if they're out of bounds. So we can say table.insert gets, and actually there's probably a better way. Let me think of the better way, because if he's walking out of bounds, we can have an entity class that just returns if it's out of bounds, and then we can say, hey, if we're out of bounds, go ahead and remove this entity from our table. So maybe that's the way to do it. We can go into our entity walk state. Now, as we're updating, we can say, this would be our trigger off screen or something, right? So trigger off screen. And we can say if our entities x plus our entities height, oh, and it's a self dot entity dot x. So if the top of us plus our height, meaning the bottom of us, is smaller than 0, meaning off the left side of the screen, then go ahead, and we need our entity to be given a value here of off screen. So we can say that our entity here has a value, and we can either do, we can either do this in our entity class, or I think we'd want to do this in our entity class. So we can say that we have a self.offScreen gets false, and we can't just put this here. We need to, and maybe that would be okay. Okay, so we still got gecko. It doesn't crash, so we should be okay there. But when we go here, we need to trigger our off screen. So it's once. We would do our trigger off screen in our entity class rather than this. And we update our entity in our what state? We're going to be updating our entity if it's in the walk state here. But we kind of need this trigger to be no matter what. Like no matter what the entity is doing, so maybe let me just take a look at our entity walk. This is our entity walk state, so when we change to it, it'll update all this stuff, but does that mean, yeah, we are rendering it here in our walk state? Okay. So does it make sense to put, I think it makes sense to put the collision detection in our entity class, because we are gonna, and actually in our update here, we just update via the state machine, so we would put it in our walking, I guess. Okay. So we're gonna say if the right, see, and this needs to be width here. We'll say if our entity's right side is smaller than the left side of the screen, then we're going to go ahead and we would want to go self.entity.offScreen gets true. And we would want to do this in a bunch of different cases. We can say if the right side of us is there, or if the left side of us, if the left side of us is greater than the virtual width, then we also know it's off screen. And then if the top of us, or the top of us is greater than the offset screen height, or what is it? Screen height limit. That's what it is. If the top of us is greater than that HUD X, no, HUD Y, then we're also going to become off screen. And if the bottom of us, self.y, and it's not self.y, it's self.entity.y, entity.y plus our self.entity height is, so we're checking if the top of us is lower and the bottom of us is higher, so smaller than 0. Now we need to make sure we spell entity right here, and this needs an entity. And then this needs an entity. Okay, so now our entity object should be becoming off-screen true if it walks off-screen. Now we can test this with our gecko that we do have by printing out that gecko's field of off-screen. So let's go ahead and see in our scene. Now we need, I want our scene to be closer to our play state here. Now we give ourselves a gecko, right? We give ourselves a gecko. It's just a random gecko, part of our field. We change its entity, we change its direction and its state. So that should initiate it walking. So our self.gecko.offscreen should be printable here in our scene, but we don't do our debugging in here, but let's just add it here for anyway. Love.graphics.print, and we're gonna say gecko off screen. We need a string here, so gecko off screen. Now we need to concatenate that with a string of the value of our self.gecko.offscreen. So this should be false until it walks off screen, and then it should change to true. And then that will be the trigger for us to remove it from our entity table. We'll just put it here. It starts off as true. So maybe we did that wrong. Entity state is false, so maybe we just did the logic wrong, because if we take that off, it is false. Now, I do think we need to figure out a different text here. I like the Link's Awakening text. It's just too big. In our dependencies, we can re-put in our pixel.ttf here. And I think we deleted it. Let's see. Pixel with a capital P. Okay, now what's the proper size? Okay, so gecko off screen is false. Now, we messed up our update here, so let's walk it through. If the left side of us plus the width, so the right side of us is smaller than 0, we're off screen, true. If the left side of us is greater than the width of our screen, off screen is true. If the top of us is greater than the screen height limit, let's just put, I'm pretty sure that's right. If the top of us is greater than the screen height limit. because the screen height limit is the virtual height minus the HUD height. And then if the bottom of us, so the bottom of us is smaller than 0, then go ahead and entity off screen gets true. So where are we messing that up? See, it already thinks it's off screen. I don't know. I mean, let's turn this off and let's just try if the self... We just want to see if the bottom of us gets smaller than the top side of the screen. So if our Y plus our height is smaller than 0, then we're going to go ahead and self.entity.offScreen. Yeah, it's true. Now, hopefully, this doesn't start off as true, and it is not. Let's see if it does. Okay, so that one's working. So that is our last one over here. Self.y plus... Okay, so let's just test our other ones, but we're not walking off those screens. So, where are we messing up here? If the right side of us is smaller than 0, or the left side of us is greater than our width, then if the top of us is greater than the screen height limit, let me check screen height limit. That's the only thing I could think of that might be screwing this. Screen height limit is virtual height minus 16, yeah. That should be right. Okay, so I guess the question is, if we instantiate our gecko with the left direction, does it crash because we don't have a left direction handled? But let's see. So go to our scene, we'll go to where we instantiate our gecko, and we'll actually change his direction to left here. And it doesn't render anything because he doesn't have... I think in our entity defs, we don't have a... Yeah. So what we'll do, we have a walk up. Let's give us the other directions. It'll be the same frames for now because we don't actually have them. But he'll have a walk up, a walk down, a walk left, and a walk right. So now it should be the same gecko, and we don't see it. What? What are we doing in our entity walk state that could be screwing this here? Change animation. Okay, so we're just manually changing this. I think we would want to change this based on our direction. So we would want to say self.entity change animation to be... Can we put self.entity dot direction? And we would need, bear with me here, if we do like, if we convert this to a string, pass in the direction, then pass in the walk field with a hyphen, and then concatenate that. So this, would that mean we would get our gecko walking direction? No. Let's see if we take this We want to literally just change this to be walk left, which we now have a table for. Okay, what is going on? In our scene, let's go back to, oh, it's not left, it's walk left here. And it's still not on. Okay. Let me see what we changed. Okay, the direction is just the string of the direction. Okay, let's see. For right now, change animation. Wasn't this up? Or was it walk up? I think it's walk up. And then we lost our gecko, ladies and gentlemen. If we go to our class here, our scene class, and we go make sure our direction is the proper direction, like up. Okay. Oh, that's the thing. We start him, we instantiate him off screen. So let's instantiate him right in the middle of the screen here. That's the first problem. So we'll say virtual height. Because he was walking left, he was just walking left off the screen, off the bottom there. So our X is going to be the virtual width divided by 2. Our Y is going to be our virtual height divided by 2. Now, we've got a gecko walking up. Cool. So if we want to shift him to walking left, we would give him a direction called left. And he's got the same animation because in our entity defs, our walk left is the same frames here as our walk up. So we're handling elsewhere our direction, whatever our direction is, we're going to change our walking animation to be walk plus whatever that direction is. So we're already handling that. So we are able to just change the direction. So now we can test this off screen is true once he goes off screen left. So let's do that. So if that one is good, let's see what our left would be, which would be, we would see if the right side of us, so the X plus our width, would be smaller than 0, then we become off-screen true. Let's see. Off-screen true. Cool. So left is working and up is working. Let's try right, and let's get in our scene. We'll go walk right here. And we're going there. He's going right. Now let's make sure we've got right configured for off-screen, which would be the left side of us would have to be greater than the virtual width. Then off-screen is true. We're looking for that. Yep, it becomes true, so that's good. Now let's try down, and down would be if the top of us is greater than our actual screen height limit, then we're off-screen true, but we need to get him moving the correct direction, so we'll go down here. Okay, that's actually, I really like the scuttling backwards. That's really cute. So those all individually are working fine. So why is it that when we ask them all at once, it doesn't work? Because we've got our entity x plus our entity width smaller than 0, yes. Or our self.entity x greater than the virtual width, yes. Our y plus, or our y is bigger than our screen height limit, yes. Or our entity plus height smaller than 0. Entity plus height smaller than 0. I don't get why that would be the case here. So if we turn this back on, okay, well, you're working now? Oh, and you know what? It was off screen because we literally spawn him off screen and walk on. So, and actually that's a good point. If we want them to become, if we want them to walk on screen, and we spawn them just outside of the screen, this function will say, hey, off screen is true, so remove it from the entity, but we don't want that. So I think what we want to do is give this one extra frame of buffer here. So I think we would just give a negative tile size here. So once it goes 1 pixel off, yeah, once it's smaller than 1 pixel off, 1 tile worth off the screen, then it becomes off screen for sure. Because if we spawn something just outside of the screen to walk in, we don't want it to be removed from the entity table. So we'll say the left side of us would have to be bigger than the virtual width plus our tile size here. And then our top side would have to be greater than the screen height limit plus our tile size. And then the bottom of us would have to be smaller than a negative tile size here. Okay. And then, okay, so it looks like it gets a whole tile size off screen before it deinstantiates, and I think that's right. So let's see if, I think that's right. Let's try the other directions again and see. Let's give it left. Okay. Right. So we need this because we need to deinstantiate it from that self entities table, and then up should be good as well. Okay, cool. So now what we want to do is add it to our entities table right here. So we'll say right after we instantiate it, we're going to say, hey, self.gecko dot. Actually, it's a method called table.insert. And we give it the list, which is our self.entities. And we pass it in the value we want to put in, which is a self.gecko. And it's this specific self.gecko, because that's what we called it. Okay, so now what I want to do is print up the values in our entity table, but let's see, if we say that this is entities number. Entity number, and we're going to put in our dot entities here. And we're going to put it 10 pixels below. Okay, we don't want the actual table. We want the number of things in the table. Cool. So we've got one entity because we've only inserted that one. So now we need to trigger, hey, if that entity is off screen, remove it. So in our update here, we would say, and this is in a entity update. So what we can do, since our entity, let me just put this up here with the other entity. Since our entity is being updated by our function, it's not even a function, it's just, shoot. Where was our off screen? Is that in our entity walk state, I guess? Okay, so as our, I don't know if it makes sense to have it here. But our entity walk state is updating its off-screen field to become true once it walks off screen. So then we just need to ask see, I think we could do an event listener here, but I don't know exactly how that'll work. Yeah. Why wouldn't we? What's tough about removing the entities is that the table.remove function only removes the index of the table, so you have to know the index. So you kind of have to cycle through the tables with a for key value in pairs, and then remove the index of whatever happens to be off screen. So for that, I think we would go into our, where would it be? It'd be our scene, I think. Okay. I think it'd be down to our update here. We update our gecko itself, but the gecko itself isn't updating. I guess I'm not so sure how this is working. Like, let's test if we can say we'd be rendering all our entities here. So I think if we do a gecko update, it'll know it's in a walking state, so it'll go to the update of all our walking state, which will give us that field. And then we can say if self.gecko dot off screen is true, equals true, then we would say table.remove. We would say from our self.entities table, remove the index 1 because we only have one gecko. So now let's see if it goes to 0. It does. So we're successfully deinstantiating our gecko at this point. Now the thing is, we can't just keep this hard-coded. We need to cycle through all our entities once we have more than one. So let's give us an army of geckos. Okay, let's go. Let's give us an army of geckos. So what we're gonna do is, instead of giving us one gecko, how would we give ourselves multiple geckos? We would say something like, for I gets 1, for I gets 1, comma 10, do something. And the something we'd want to do is say that we would want to table.insert into our self.entities table, and the value would be an entity instantiation that we declare like this, and we need to give it X amount of values here. Now, so that we don't give them all the same x position, we could say x gets a math.random value of the virtual width -2, -10, and +10, so like a 20 pixel random x position here. And then y will be the same. We'll just make it so that it is actually virtual height. So we'll substitute our width for our height globally and make sure we add the commas. Okay, same width, same height. Okay, now we need to also manually, and this is our, oh crap. Stream crashed. Sorry guys. We're trying. Still down. Okay. Sorry guys, I don't know why my stream just craps out sometimes. I've got fast enough internet. Okay. I think we're okay. Okay, we have to also give them a random direction. But for now, yeah, and we have to set their state machines, so they have access to each entity state machine. Now, this is the equivalent of our old, when we had just one gecko, but we need to give them a direction here. So we'll say that the direction gets, let's just say up, and then we need to make sure that its state machine gets, nope, not like that. State machine also gets a table of keys and values of these function returns for our state machine. Okay. And then what we can do is comment this old stuff out. So now for every entity, we're saving its animations. We're giving it a random X and Y, giving it a same direction, giving it access to these state machines. We're doing this for 10 geckos. Now what we need to do is update all our geckos. So I think what that means is instead of updating a gecko here, we would need to cycle through all our entities. So we would say for I gets 1 as long as the number of self.entities do a self dot. And you know what? How do we do this? It's just an index, I guess. Oh shoot, man. Our stream's crashing tonight. Well, that sucks. That really sucks. Man, that sucks. I think it's just by index here. Wow, we're really crapping out tonight. That's a bummer. Yeah, Leva, I don't know what's going on. I've got fast enough internet, it just craps out. Yeah, I don't know what's going on. It's just, I really, and what's weird is like, I paid for faster internet and we're getting those faster speeds. It's just that in the past couple days, it's been crapping out. It was like solid for like 2 or 3 weeks straight, and then I've been having problems recently. Anyway. So we want to update every gecko in our entity list, but I'm not so sure how we can do that. Because we can say for our entities, we would want to go into our entities table. We would say entities table at the index of our I, and then run our update on that. So that should update every of the 10 geckos, like this was doing it for one gecko. And then we would also need to check if that gecko is off screen. So we would say self.entity. Yeah, we would say this same kind of thing. Entities at that ith position dot off screen. If that is equal to true, meaning that gecko has walked off screen, then we would go ahead and table.remove from our self.entities table the index of our ith gecko. And that should be the equivalent of this was for one gecko. So let's see. Scene 28. Okay, we need to close our entity. Oh, we are. Hold on a sec. Yeah, we need to close. Yeah, we need to close our parentheses for our entity. So this should have. No, this should have a parentheses there. Nope. Oh, that should be right. But we're crashing somewhere else. Oh, yeah. See, and this is why we get screwed. We want to pass in the reference of this current entity. So this... I think this would just be self, because it's the scene. But then this would be the self dot... Oh, this... I'm not sure. I'm not sure. Let's take a look at our entity walk state and see what it requires. It takes in an entity, so what the entity itself we need to place in this walk state. So how do we place the entity itself? Now self, since we're in our scene class, self is the actual scene, not our entity, I would think. So how do we pass in this is its own entity? I guess it would be self entities at that ith location. Maybe. And then this would be the same. Oh, we're crapping out again. Shit. I'm going to take a look at how my... the CS50 game dev repo does it here. I'm just going to take a look at how they initialize the state changes for spawning a whole bunch of entities. So okay, this is what they do. They store their entities at the ith position into an entity variable, and then they can just access it with entity, but where do they do the state machine? Here, this is what I'm worried about. Or shit, this is what I wanted to see. They literally just take in an entity. Now, their game is different than ours. Theirs has dungeons that just randomly generate and don't have kind of memory for those entities. They just get reset to random. So we actually have a different way of doing this. But we do, and see, they do it outside of the entity definition so that it already exists, and then they assign it based on that ith position. So still in the for loop, but outside of the actual entity definition. And same with the state change. So let's do that for ours. Now we'll take this out of the entity definition, but still in the for loop. And we'll place it here. Okay, now that is what they did, right? Entities at I, yeah. Now our walk state has to have a reference to our scene. So that's why we pass in a second argument of self here. So let's see. State machine's crashing. So it's not that it's a state machine, it's that it's a self entities at the ith location dot state machine. Okay, 170 on scene, we're crashing because our gecko is still being rendered, even though it doesn't exist. So let's just comment that out. And maybe we'll have 10 geckos. Nope, 172, dude. Okay, yeah. It says we've got 10 entities, we're just not rendering them, and our stream crapped. Mother. Why? Why? This is annoying, man. I'm gonna call Xfinity. I'm gonna call Xfinity and see what they've got, because this is just awful. I'm paying out the ass for internet too, like paying over $100 a month. Okay. So we're not updating our entities. Actually, yeah, we are. We're not rendering our entities, so we need to do that. So we'll say for I gets 1, comma, number of self.entities. Do. Yeah, sorry for the crapping out stream, guys. I'm gonna talk to my ISP and hopefully they can know what's going on. Yeah, we want to render each of our entities. We've got 10 of them, so we just need to make sure we're rendering them, and we would do self.entities at our ith location. Render. It's not quite it. Let me see what they're doing in theirs for render. They literally go, if entity not dead, render, but we need to give it the X position and the Y position. Now, we don't really have that actually. I wonder if we can just, let's see if our entity class requires render parameters adjacent X offset. So they're kind of optional because we do set some default values here. And the adjacent X offset is never getting assigned. So I don't know why we still have that, but we're close. I want to say we're close. Okay, let's see if the entities disappears. Like, see if they should disappear. Okay, they're not disappearing either, so maybe it's not updating. We're not changing our state. That's really bugging me, man. What do I even do to fix this? There's nothing I can do. Okay, yeah, sorry for the stream issues, everyone. That is not fun. I'll call Xfinity tomorrow. Yeah, because I pay over $100 a month. It shouldn't be crapping out 15 times during the stream. So, we'll see if they can do something about that, because I pay them too much money for that to happen. We need to make sure we change our entities into getting the walk state, which we would say entity walk. Is that right? It's not just our entity, it's entity at the ith location. Oh! Did you guys see 10 geckos? Did you guys see 10 geckos? Now, what's weird is we populate it with a direction of up. So, why would they be going down? That's cool, that's cool. It's an army of gecks. But they're just going the wrong way. Now, we are changing our direction. We're changing our direction, so I don't know why they're walking. Because look, we do that. We change the direction to get a string up. We change it to an entity walk state. So why are they walking down? Our entity class here gets a direction of down. So maybe that's overriding it. Yeah. Oh, yes, dude, an army of geckos. So why is it that this direction overrides the direction that we give it ourselves? I think it's like we assign it and then it gets initialized and then it gets initialized and overwritten. So it's almost like we need to define this outside. Like, it's nice to have a default walk variable for the entities, but we need to make sure that we assign it and not override it. So we'll give it the string up here, Now let's give us a bigger window of random x values. So let's do minus 40 and plus 40. And then a minus 20 and a plus 20 for the y. And we'll see if that spreads out our gang a bit. Yes. Okay, so we're still crashing at scene 137. But this is so handy to try to be able to spawn a bunch of stuff like this. This is really cool. So 137. We're updating a gecko that might be removed. So I don't know how to handle this. Attempt to index a nil value. So it's like, how would we? They've got. Let's see the this thing. So when they in Zelda repo here, they're coming here and we're looking more stable now, at least. Oh. Okay. Yeah, we need to do it in a table like this instead of a for loop. Because then we have access to the variable entity instead of an entity at an ith location or whatever, so that's a better way to do it. So let's do that. Instead of the for loop, we'll say for key entity in pairs of self.entities, do where we say if not, and you know what, they do it different. They don't remove it from the table if it goes off screen like we're doing it. They just say if it's dead, take it out. They're not actually, at least I don't think they're stopping updating if it's dead, or maybe they are. Let's see. If it's dead, okay, so they only update and process if it's not dead. So they are doing something kind of smart like that. Okay, just want to make sure. Oh my god, dude. Why is the stream crapping out? This is awful. This is bad. Okay. Wow. Yep. Shit, dude. This is bad. I hate this. We're dropping frames like crazy. What is going on? I don't know, I feel like since the month changed, Xfinity kind of like dumped me back to crap internet. Well, I'm getting 19 megabits upload speed, which should be good enough. And you know what? Yeah. Shoot. Sorry, guys. Okay. Yeah, I'm gonna call Xfinity tomorrow because this is really sad. Okay. I don't know if I should lower my settings or what. Let me lower my settings and we'll try again here.